TOAN. Hello everyone. I'm glad to see you in the Super Memory for Schools program. Today we will study Chapter 1, Lesson 1 and 2, Square root expression and identity. The square root of a square is equal to the absolute value of a. Our lesson today consists of four main contents. The first part is the introduction to the square root. The second part is the comparison between the square roots. The third part is the square root expression, and the fourth part is identity. The square root of a square is equal to the absolute value of a. Let's learn about the square root. Students, please solve the following problem. Write the following numbers in the squared form of a number. Here we have 25, 49, 0, and negative 36. Please take your draft and do with me. We have 25 equals 5 squared. Also, 25 is equal to the negative 5 squared. 49 is equal to negative 7 squared. 0 is equal to 0 squared. And about negative 36, we cannot find any squared number that results in a negative number. Because 5 squared is equal to 25, we say the square root of 25 is 5. And we sign the square root of 25 is equal to 5. Similarly, negative 5 squared is equal to 25. So we say the square root of 25 is negative 5. And we sign negative of the square root of 25 is equal to negative 5. Because 7 squared is equal to 49, we say the square root of 49 is 7. And we sign square root of 49 equals 7. Similarly, negative 7 squared is equal to 49, so we say the square root of 49 is negative 7. And we sign negative of the square root of 49 is equal to negative 7. Because there is 0 squared equals 0, we say the square root of 0 is 0, and we sign square root of 0 equals 0. Because negative 36 is a negative number, we don't have the square root. So when do we say the square root of a is x? With the condition a is a non-negative number. The square root of a with a is a non-negative number. It is x when x squared equals a. And that is the first content of part 1, the square root. The square root of a non-negative number a is x when x squared equals a. Please keep observing. Here, 25 is a positive number, and we find out that it has two square roots, the square root of 25 and negative of the square root of 25. 49 is also a positive number, and it also has two square roots, which is opposite to another, the square root of 49 and negative of the square root of 49. About 0, it has the square root, which is 0. Here I have a. A is a positive number. How many square roots will it have? The positive constant number a will have two square roots, which are two opposite numbers. They are a squared and negative a squared. So we know the next content of part 1. The positive number a has two square roots, which are two opposite numbers, the square root of a and the negative square root of a. 0 has the square root, which is itself. And here the square root of a also has another name, which is the arithmetic square root of a. So we have the definition. With the positive number a, the square root of a is called the arithmetic square root of a. And 0 is also called the arithmetic square root of 0. So with a is a non-negative number, we have the arithmetic square root of a equals x. And it has to satisfy the condition, which is x is greater than or equal to 0, and a equals x squared, and vice versa. If we have x is greater than or equal to 0, and a is equal to x squared, we conclude that the square root of a equals x. So this is a two-way theorem. We will apply these notes in the following problem. Example 1. Find the square root of each of the following numbers: a, 49, b, 64, c, 81, d, 121. Question A. We have the arithmetic square root of 49 is 7. Because it satisfies two conditions, which is greater than or equal to 0 and 7 squared equals 49. We have the arithmetic square root of 64 is 8. Because 8 is a non-negative number and 8 squared equals 64, the arithmetic square root of 81 is 9. Because 9 is a non-negative number and 9 squared equals 81. And similarly, the arithmetic square root of 1.21 is 1.1. Because 1.1 is a non-negative number and 1.1 squared equals 1.21. So we have finished example 1. The arithmetic square root part. With a as a positive number, the square root of a is called the arithmetic square root of a. and the arithmetic square root of 0 is itself. With number a as a non-negative number, the arithmetic square root of a is x. When x is greater than or equal to 0 and a equals x squared, we move to part 2, which is comparing the arithmetic square root. We have the following theorem. With a, b are two non-negative numbers. We have a is less than b, equivalent to the square root of a less than the square root of b. This is a two-way theorem. We will apply this theorem in example 2. Compare question A, 4 with the square root of 15. Question B, 3 with the square root of 11. In question A, we have 4 is equal to the square root of 16. So to compare 4 with the square root of 15, I compare 16 with 15. We have 16 is greater than 15. So applying the theorem above, we infer that the square root of 16 is greater than the square root of 15. And the square root of 16 is equal to 4. So 4 is greater than the square root of 15. So we finish question A. In question B, we have 3 equals the square root of 9. So we will compare 9 with 11 because 9 is less than 11. So accordingly to the theorem above, we infer the square root of 9 is less than the square root of 11 and infer 3 is less than the square root of 11. So we have finished question B. We continue to solve example 3. Find the non-negative number x. Question A. The square root of x is greater than 1. Question B. The square root of x is less than 3. We have 1 is equal to the square root of 1. So the problem for the square root of x is greater than 1 means the square root of x is greater than the square root of 1. So with the conditions and according to the theorem we have just studied, and here x is a non-negative number, we get x is greater than 1. So we conclude that x satisfies the condition that it is greater than 1.
In question B, we have 3 equals square root of 9. So the problem asks x is less than or equal to 3, which means x is less than square root of 9, or x is a non-negative number.
So at least according to the theorem and the condition, we get x is greater than or equal to 0 and x is less than 9. So we finished example 3. So I have just introduced about part 2. It is comparing the arithmetic square root. And please remember, with two non-negative numbers, a, b, if there is a is less than b, we infer that the square root of a is less than the square root of b, and vice versa. If the square root of a is less than the square root of b, we infer that a is less than b. This is a two-way theorem. We have the next part, which is the square root expression. With a is an algebraic expression. We call the square root of a is the algebraic square root of a. And a is called the radicand, or the expression under the radical expression. And similar to the square root of a number, the square root of a is determined means the condition of a is greater than or equal to 0. Especially here, I have the square root expression of 5 minus 2x. This square root is determined or having meanings when the radicand, which is 5 minus 2x, is greater than or equal to 0. Here, we will solve the inequality equation. And note, for me, when we do transposition of formulas rule, divided multiplied by -2. Moving to the right means dividing by -2, so the inequality equation has to be reversed. So I have finished introducing the content of part 3, square root. And you need to remember two main points. When a is an algebraic expression, the square root of a is called the square root expression of a, and the square root of a is determined when x is greater than or equal to 0. We move to the next part, which is identity. The squared root of a squared is equal to the absolute value of a. We have the theorem. With every number a, the square root of a squared is equal to the absolute value of a. We solve example 5. Question A. Square root of 12 squared. Question B. Square root of -7 squared. In question A, if we see the square with radical sign, we will replace it with the absolute value sign. Because the absolute value of 12 is positive, its absolute value will be equal to itself. In question B, we replace the square with absolute value, so we get the absolute value of -7. So because -7 is a negative number, its absolute value is the opposite number, which is 7. We will do the example 6 next. Simplify. Question A. Square root of the expression square root of 2 minus 1 squared. Question B. Square root of the expression square root of 2 minus square root of 5 squared. We see square with radical sign, so we change into the absolute value of the expression square root of 2 minus 1. And the expression in the absolute value sign is positive. Because the square root of 2 is greater than 1, so the absolute value of a positive number is itself. We get the result, the square root of 2 minus 1, and we explain the square root of 2 is greater than 1. In question B, the square with the radical sign, we change into the absolute value of the expression square root 2 minus square root 5, and we see that 2 is less than 5, so the expression in the absolute value sign is negative. So we change the sign and get square root of 5 minus the square root of 2, and we explain that because 5 is greater than 2. We have the following general content. With a as the expression, we have the square root of a squared is equal to the absolute value of a. We have two situations. The absolute value of a is itself, or if a is a negative number, the absolute value of a is the opposite number of a. If a is less than 0, we will apply this content in example 7. Simplify. Question A. We see that the square root of a squared is replaced with the absolute value sign. Where x equals negative 2 is a positive expression because the problem gives x is greater than 2. The absolute value of a positive number is itself, so we get the result is equal to x minus 2. Explain because x is greater than 2. In question B, we see a to the power of 6. We bring it back to the form a cubed to the power of 2, and squared with the radical sign outside, we change it into the absolute value sign, so we get the absolute value of a cubed, and the problem gives a negative number, so a cubed will be a negative number. So the absolute value sign will be changed into negative a cubed, and we explain because a is less than 0. We continue doing lesson 9 in the textbook, page 11. Find x knowing that a square root of x squared equals 7. Here, the square with the radical sign change into the absolute value sign, so we get the absolute value of x equals 7. Here, 7 is a positive number, so we will find two situations, which is x equals 7 or x equals negative 7. So we get the solution set s equals 7, negative 7. In question D, we have square root of 9 multiplied by x squared is equal to the absolute value of negative 12. Here, the absolute value of negative 12, we will calculate and have the result 12. And about 9x, we bring it back 3 times x squared. Square with the radical sign we replace is by the absolute value sign. So we have 12. And because 12 is a positive number, removing the absolute sign, we have two situations, which is 3x equals 12 or 3x equals negative 12. And we solve each situation and get x equals 4 or x equals negative 4. So we have the solution set s equals 4, negative 4. So through today's lesson, you have known how to identify an arithmetic square root, how to compare two arithmetic square roots, as well as how to find the determined condition of the square root expression, and know the identity. The square root of a squared is equal to the absolute value of a. Our lesson today ends here. I'm sure that after today's lesson, you had enough knowledge and confidence to solve the problems relating to the arithmetic square root, as well as the square root expression, right? Wish you a lot of health to have fun and study. See you in the Super Memory for Schools lesson next time. Goodbye!